Good morning, Professor. We are honored to be here today to present. Our work is assessment of the adsorption efficiency of nickels in water environment of polymer-based materials, a case study for environmental education for students. Our team, Hanoi, Vietnam. This study evaluates the nickel adsorption capacity of adsorbent composite from polymer and copper oxide, referred to as PAC materials. The adsorption process of nickels on PAC materials is consistent with Langmuir isotherm adsorption models. Experimental results show that the maximum adsorption capacity of nickels on PACs achieve very good results compared to other materials. The time to reach adsorption equilibrium was 100 minutes. The optimal pH was 4. Metal oxides such as aluminum oxide, copper oxide, iron oxide are materials capable of removing some heavy metals from the aqueous environment. However, because these metal oxides often exist in the form of nanometer-sized fine particles, when used in aqueous environment, will be very difficult to recover.
In this study, we paired copper oxide with polyacrylonitrile (PAN) to disperse and localize the metal oxide crystal lattice in the PAN network created by chemical bonding, limiting the leaching of copper oxide when using adsorbent material aggregates in the aquatic environment. Characterization for PAC composite and the adsorption properties for ZN in the aquatic environment was investigated. In this paper, we used PAC composite to adsorb Ni2 plus nickel ions and evaluate the process of teaching environmental education for high school students at the University of Education, Hanoi National University Interior.
Now let's move on to the results of experiments. Figure 1 shows that adsorption was the best technique for wastewater treatment out of the method tested. As shown in the figure 2, the EDS picture indicates the elemental composition of our material PAC, suggesting that it was a successful synthesis for nanomaterial PAC. The optimal pH was discovered in our experiment after experimenting with pH value ranging from 1 to 8. As shown in figure 3, it shows that pH 4 is the most effective for nickel removal. Lastly, when we look at the figure 4, we can see that it demonstrates the adsorption capacity of PAC increased with time. The absorption time was mainly occur in the first 30 minutes. After 100 minutes, the absorption has reached a 95%, which is equilibrium.
In this project, we investigated the factor affecting the absorption of nickel of PAC material and concluded some issues as follows. The time to reach absorption equilibrium is 100 minutes and the optimal pH is 4. The absorption process of nickel on PAC material suitable for Langmuir isotherm absorption model. The process of preparing PAC nanocomposite materials has been introduced in an easy, simple, and low-cost way. In summary, PAC materials have advantage for removing heavy metal nickel in addition to aqueous media.
In this study, we use a few remedies that you can see. We look forward to your question to improve the quality of this study that you can see on the poster.